Hey guys, today we will learn about Euclidean algorithm in number theory. Before that, I hope you guys are all in a good condition since we are in a pandemic of COVID-19. So let us start. The Euclidean algorithm is a method for finding the greatest common divisor or GCD of two positive integers. It's a very old method for around 2,300 years. It first appeared in Euclid's Elements. What makes this method powerful is you don't have to factor the numbers to find the GCD. Before that, let us try to understand how the algorithm works. So the algorithm takes two positive integers, which we'll call A and B. And these two numbers don't necessarily need to be positive. If we had any negative numbers, we could just take the absolute value to make them positive. And then, our algorithm will work exactly the same. We're assuming A and B are not equal. Since if they are equal, then obviously, the GCD is just itself. And we're also going to assure that A is greater than B. If in fact, B was greater than A, then we could just switch the variable names and call B as A and A as B, and it would work exactly the same. So, the first step is writing A as B times a quotient Q plus remainder R, where we have R is greater than or equal to 0 and less than B. And we know that we can find these unique integers Q and R from the division algorithm proof. Now, the next step is doing this exact same thing that we did above, but now using the integers B and R. So we're going to write B as R times the quotient, which we'll call Q1, plus this new remainder, which we'll call R1, where we know that R1 is greater than or equal to 0 and less than R. And then we'll repeat the process, this time using R and R1. So we'll write R and the multiple of R1 plus a new remainder R2. And we'll continue to add this until this remainder here is equal to 0. So, we'll say for some R sub I minus 2, we can write that as R sub I minus 1 times Q sub I plus R sub I, and then the very next one will be R sub I minus 1 equals R sub I times Q sub I plus 1, where we have remainder is 0 now. So, this notation gets a little ugly when we have to write it out, but the point is that you can just continuously repeat this process until the remainder is 0. Then, once we do that, we get the last non-zero remainder is the GCD. So since the R sub I was the last non-zero remainder, this will tell us that the GCD of A and B is equal to R sub I. So, let us have an example to clear it up a little bit. Let's say we wanted to find the GCD between 192 and 270. The first step is to write 270 as a multiple of 192 plus remainder. So we get that 270 equals 192 times 1 plus a remainder of 78. Where of course, 78 is a unique remainder that is greater than or equal to 0 and less than 192. Now, we're going to do that the same thing, but this time, we're going to do it with the integers 192 and 78. So bringing 192 down here and 78 down here, we get that 192 equals 78 times 2 plus a remainder of 36, and then repeating the process, now moving 78 to the left side and 36 down here, we get 78 equals 36 times 2 plus remainder of 6. Continuing, we get 36 equals 6 times 6 plus a remainder 0. And since the last non-zero remainder was 6, that tells us that the GCD of 270 and 192 is equal to 6. Hopefully, you can see now how the algorithm works. Thanks for watching guys. I hope you learned something. Please like and subscribe.